Hi, my name is Upkash and I'm going to present our project on power plant conversion in Nova Scotia from coal-fired generator generation plant to gas or other fuel. So firstly, I'm going to introduce our company as you see on the PPT. Our company name is Black Gold Limited. It is a US based company having experience of more than 5 years in replacing coal fired power plant to natural gas. We worked almost on 25 projects of power conversion in US. So the question here is why we are going to convert. What is the importance of converting a coal fired plant to other fuel plants or you can say natural gas plant. The reason is to reduce carbon emission or to reduce pollutants emitting out from the power plants, coal fired power plants. So, other thing we are going to uh, emphasize is there are two methods of conversion. One is NGCC, which is also called natural gas fired combined cycle, and the other one is convert boiler, which is called in which we are going to convert the boiler of a coal-fired steam plant to burn other types of fuel as well, other type of fuel such as biomass as well. And next thing I'm going to tell about is we our first project in Canada is in Nova Scotia province and it will start in 2022. So in description I'm going to tell about currently there are 34 power units operated in Canada. The provinces are where these plants are Alberta, Saskatchewan, New Brunswick and Nova Scotia. Almost 10% of overall coal capacity is in Nova Scotia. Currently in Nova Scotia there are four generating stations which are operating and as you see on the PPT, which is Lingen largest power plant, Lingen plant generating plant. It's the largest power plant in Nova Scotia, having a generating capacity of 620 megawatt. The second one is Point Akoni, which has a capacity of 171 megawatt. The third is Point Tupper, which is 154 megawatt capacity, and the last is Trenton, having capacity of 307 megawatt. Other than these, there is other infrastructure which generate electricity, in which one is Tufts Cove, which is the only natural gas operating power plant in Nova Scotia. If I talk about renewable energy, there is one biomass power plant in Port Hawkesbury, which generate almost 60 megawatt electricity. So here the question is, what are the pollutants which are emitting? What are the pollutants which are emitting from these plants? The main pollutants are NOx, sulfur dioxide, mercury, particulate matter, which is P2.5, you can say that, and greenhouse gases. So to cut down these emissions, cost-effective alternatives are natural gas and renewable energy. You are going to see in other slides, which is presenting by uh, my classmate. He'll tell about that how natural gas is more cost effective than other renewable energy.
Hi, my name is Aman, and I'm going to talk about the brainstorming and the most optimum idea and why we chose Point Tupper instead of the other plants. The main reason why we chose Point Tupper is its access to the Maritimes and Northeast pipeline, which runs from Goldboro to the fractionation plant in Point Tupper, which is only 2.7 kilometers away. The other plants do not have access to any pipeline, which is in close proximity. So having a pipeline built would be a massive expenditure, which is why we chose Point Tupper. And why we chose natural gas instead of biomass, coal, or wind is biomass. In case of biomass, biomass is cleaner than coal and it is renewable, but it has an effect on the environment that we cannot eradicate. It degrades soil quality and it leads to unnecessary deforestation beyond what we need in case of peak demands. And we chose natural gas over wind because wind is an expensive investment. The wind farm in Point Tupper costs around $60 million, and to have another windmill that would have the same capacity as we need, it would be way more than $60 million. And also, it depends on the climate. So we went with natural gas because it is relatively cleaner and it is easier and affordable to get access to. So the next problem is transporting the natural gas to the power plant. We could either do it via trucks or a pipeline that we can build specifically, or through the sea route, which we have a port which is quite close to the fractionation plant, probably less than 4 or 6 kilometers. And so that is one option, but the best option that we found was to build a pipeline which would be reliable and it is cost effective. And the expenditure would be as follows. Um, the pipeline would need a compressor station, which would cost around $1,712 per horsepower based on the capacity of the pipe we need, which we found out according to the hours that we need to run it and the maximum output that we need, that is 155 megawatts. So we would need around 6.9 million cubic feet of gas, and according to the calculations, we would need around 0.24 cubic feet per second of supply to the power plant. And the pipeline that runs from Goldboro to Point Tupper is an 8-inch pipeline, which has a capacity of 3.56 cubic feet per second, which is sufficient, but it does not go up to the power plant. Instead, it reaches to the fractionation plant. So to build a pipeline from the fractionation plant, we would need around $800,000 based on an estimate for a 4-inch pipeline, which costs $400,000 per mile. And the distance is 2.7 kilometers. So we calculated it to be around $8,000, $812,000. For a 2-inch pipeline, it would be much less than that because the estimate is according to a 4-inch pipeline. Assuming that the turbine and the generating system would not have to be replaced because they would run on natural gas as well. So that is an expenditure that we would not have to go through. That is our assumption. And if we still run it in tandem in a combined cycle, along with the boiler, which runs on either coal or biomass, we could have a higher efficiency and we would need much less natural gas to have the same amount of output. So the cost of natural gas is around $3 United States dollars for 1,000 cubic feet. That comes to around 29,000 Canadian dollars for 6.9 million cubic feet of gas. So adding all the expenditures, it comes down to $851,000, which is much less than the wind, which was $60 million for the wind farm, $200 million for the biomass plant, and completely converting it from coal to natural gas would need replacement of the boiler itself. So assuming we don't need that, our cost is much less than all of those. The conclusion is natural gas burns much cleaner than coal, and it is cheaper and would need much less investment. And the fractionation plant is only 2.7 kilometers away, and there is a pipeline that already exists. So we do not need a lot of new infrastructure, and we can gain access to natural gas through the port as well. Thank you.